To understand electrical safety, you need to understand some basics of electricity. Electricity works by the flow of electrons through a conductor. Okay, the flow is going to be the current, and the conductor can be many things like copper, steel, aluminum, or a human. So, to create that flow of electrons, you need to have a circular path, and that's called a circuit. If the path is broken, the electricity, this flow of electrons, is going to be seeking out the path of least resistance back to the earth. So that may be through you. You may now become the conductor. So less than 1 amp of electricity is enough to kill you, so we have to be careful. Another concept you need to understand is that the cord that we use with our power tools will have a hot and a neutral. The hot is going to be what the electricity is going out on, and the neutral is what it's going back on. So when you plug a tool in, it's going to be getting electricity to the trigger. You pull the trigger, then it flows through the motor and everything, and then it runs back on the neutral. It has to make that complete circuit. So if it doesn't, then we have a problem. So that electricity is escaping somewhere else and trying to ground itself out somewhere else. So to help us be more safe and to prevent any injuries, we can use 3-wire cords. So that ground, the extra wire, because it has the hot, has the neutral, and in that third wire is going to be the ground. It provides an alternate path back to the ground. So hopefully it won't be you, it'll use that ground wire. Also, you can use tools that are double insulated. Look for that symbol, the 2 boxes like that. That's double insulated. That is safer than a 3-wire cord. Also, use power that is GFCI protected. That means it's ground fault circuit interrupter. That is what a GFCI is, and what that does, it monitors the electricity flowing out and flowing back in, and it will trip and it will disengage the power if there's a difference of 5 milliamps, and it will trip at 1/40th of a second, so it's very quick. It's like a little mini circuit breaker right there at the outlet. Also, don't use metal ladders. Inspect your cords and plugs. Make sure the cords aren't frayed, and check for the prongs on your plug that they are intact and nothing is jammed in the female end of the extension cord. Also, we can use an Assured Equipment grounding conductor program. What that is where you go through and you're inspecting all your cords to make sure you have a continuous ground, a continuous power, and a continuous neutral through your cords, that the wires within the cords aren't, there hasn't been any damage where the wires are touching each other, but it is one continuous cord all the way through for both the hot, neutral, and the ground. That is the Assured Equipment grounding conductor program. You need to have a written description, a competent person in charge of that. You need to visually inspect your cords, and before use, after repairs, and after you think there's been damage, and every 3 months they have to have this continuity and terminal testing to make sure they're good. And then they are marked appropriately. You'll have a document that shows for each quarter, which is every 3 months, what color those cords should have. Like it might be blue for the first quarter, and at the end of each cord you would have some blue tape or some blue marking, and each quarter it will change, and that needs to be documented.